Hello, Ayush. How can I assist you?
Can you explain the difference between population and sample?
Sure. In general terms, a calculation refers to the process of determining a numerical result using mathematical operations, while a sample is a subset of a larger population used to represent that population in analysis. For example, if you're calculating the average height of students in a class, you might take a sample of a few students rather than measuring everyone. Do you have a specific context in mind, like statistics or something else? I'm here to help.
What is random sampling and why is it important?
Random sampling is a technique where each member of a population has an equal chance of being selected to be part of a sample. This method helps ensure that the sample represents the population accurately, reducing bias and allowing for generalizations to be made from the sample to the larger group. It's important because it enhances the validity of research findings, making the results more reliable and applicable to the entire population. Without random sampling, the results could be skewed, leading to incorrect conclusions. Are you diving into a research project or just curious about sampling methods? Let me know.
What are the different types of sampling methods and when would you use each?
There are several sampling methods, each with its own purpose and application. Here are some common types. 1. Simple random sampling. Every member has an equal chance of being selected. Use this when you want a representative sample without bias. 2. Stratified sampling. The population is divided into subgroups. Strata and samples are drawn from each, ideal for ensuring representation across key characteristics, like age or income. 3. Systematic sampling, selecting every nth member from a list. This is useful when you have a large, ordered population and want a quick way to sample. 4. Cluster sampling, the population is divided into clusters, often geographically, and entire clusters are randomly selected. Good for large populations spread over a wide area. 5. Convenience sampling, selecting individuals who are easiest to reach. While it's quick and easy, it can lead to bias and is less reliable. 6. Quota sampling, similar to stratified sampling, but instead of random selection, you fill quotas for specific subgroups. It's useful when you need specific characteristics but can introduce bias. Each method has its strengths and weaknesses, so the choice depends on your research goals, the population, and available resources. Which one sounds most interesting to you, or are you considering one for a project?
How would you minimize bias in data collection?
Minimizing bias in data collection is crucial for obtaining accurate and reliable results. Here are some strategies to help you achieve that. 1. Random sampling. Use random sampling methods to ensure every individual has an equal chance of being selected, reducing selection bias. 2. Clear definitions. Define your variables and categories clearly to avoid misinterpretation and ensure consistency in data collection. 3. Training for collectors. Train data collectors to follow protocols strictly and understand the importance of neutrality and objectivity. 4. Pilot testing. Conduct a pilot test of your data collection process to identify potential biases and refine your methods before the full study. 5. Anonymity and confidentiality. Assure participants that their responses will be anonymous, which can encourage honesty and reduce social desirability bias. 6. Use multiple sources. Collect data from various sources or methods, triangulation, to validate findings and reduce the impact of any single source's bias. 7. Monitor and review. Continue